Okay, now let's talk about a super important piece of trigonometry, and that's our special right triangles. Um, Special right triangles are extremely important because they are the basis for the unit circle. So learning them now will just make it that much easier when you get to this section in pre-cal. So we have two special right triangles, and these ratios really only work for them. The first one is when you have a right triangle that has a 45, 45, 90 degree. That means that two of the angles are 45 degrees, and then, of course, it's a right triangle, so we have a 90-degree angle. So we have these special ratios, and so you'll see this note that says the legs of a 45, 45, 90 are always congruent. Each leg across from that 45 angle, we call x. So our legs have the ratio of x, and then our hypotenuse, if we were to do the Pythagorean theorem here, x squared plus x squared, we would actually solve and see, there's that one little line spot, that it's the hypotenuse is actually the ratio x times the square root of 2. So what that means is if a leg was the length of 2, then that means our hypotenuse would be 2 square root of 2. So we're just finding those, using this ratio to find all of the missing lengths. So if you look here, we can see that we are given a leg. So that means that x equals 8. Now this can get confusing because you'll see that we have everything with x and y. So that just means we're going to go ahead and say, well, this side has to be 8. So x, yeah, it does equal 8. And then that means that our hypotenuse is whatever that value of x is times the square root of 2. So it's 8 square root of 2. So that's super simple, but let's say it's not so simple. So you'll see in this one, we are missing our legs, but we are given a hypotenuse, and it doesn't have the square root of 2. If it was like 2 square root of 2, then we would know that x was 2. That would be easy, but this is not going to be easy to us. So what we're going to do is set up an equation to solve for x. So we know that that leg is the same as this ratio. And now let's solve for x. So we're going to divide both sides by the square root of 2. And then that's our answer. But remember, we can't have a radical in the denominator, so we need to multiply by the square root of 2 over 2. That's going to give us 19 square root of 2 over the square root of 2 times the square root of 2 is just 2. And there's our answer. That means that both of those legs are 19 square root of 2 over 2. And that's our answer. So that's for a 45, 45, 90. Now let's talk about 30, 60, 90. Okay, so our ratios for here, the shorter leg, it is always opposite the 30 degree. So it's here. And our shorter leg we're going to call x. Our longer leg is across from 60 degrees. So it is this leg. And it is x square root of 3. And then our hypotenuse, which is across from our 90-degree angle, is 2x. There's that line, driving me crazy. All right, so there's our ratios for a 30, 60, 90. So now let's put that together. Let's solve some of these problems. All right, so you want to find the value of each variable. Across from 60 degrees, remember that's our longer one. So this is going to be x square root of 3. I'm just going to write in our ratios. Across from, that means that this is our 30 degrees. That means this is our x, and that means this is 2x. So you can see right away that this is going to be an easy problem because our x ratio is 5. So if we're finding this value, that means that here we just put in 5. So it's 5 square root of 3. And then this y is 2 times whatever our x is, so it's 10. I know this can get really confusing with the x's and the y's and our ratio being in terms of x. So if you need to change, sometimes I say change these to a and b so they're not so confusing with the x. Okay. So let's look at this example problem where I just changed everything to A and B. Across from 30, remember, that's our X. Across from 60 degrees, which would be this B, that is our X square root of 3. And then across from here is our 2X. So you'll see the number we're given is our 2X. So we're going to solve for X. So 32 equals 2X. And that means that X equals 16. So A would be 16 and B would be 16 square root of 3. All right, let's look at this next one. Again, let's change this to A and B. Just makes it easier. And then let's write in our ratios. So across from 30 degrees is our B. That's going to be our X. Across from 60 degrees is our X square root of 3. And across from the hypotenuse is 2X. So you'll see, again, easy. 46 equals 2X. Let's solve for X. That means that X equals 23. So that means our A here is 23 square root of 3, and our B is 23. All right, let's do a little bit of harder one. Again, let's change this to A, B, A, B. Okay, across from 30 degrees is our X. Across from 60 degrees is our X square root of 3. And across from the hypotenuse, or 90 degrees, is 2X. Our hypotenuse is 2X. All right, you'll see this is fairly easy as well because we can tell this is 9 square root of 3, and so that means this is our X. So that means A is 9 and B is 2 times 9, which is 18. Okay, now let's put them together. Now we're going to see how we can solve all these with combinations of both. So looking at this first one again, this is a 45-degree triangle. That means that 28 degrees is our hypotenuse. Remember, that's X squared root of 2. So let's solve. So 28 equals X squared root of 2. That's going to give us that value that we're going to be putting in for X and Y. Okay, so we multiplied numerator and denominator by the square root of 2. That gives us 28 square root of 2 over 2. And then we simplify. 28 can be divided by 2, which gives us 14 square root of 2. And both X and Y are the same because remember on a 45, 45, 90, they're the same. Let's look at the next example. So again, I'm going to change this to A, B, and C so that when we're talking about our ratios, it's not confusing. Okay, so again, we have a leg of our 45. So we know that this leg is 32 as well, right? And that means we can also find A because that's just that leg value times the square root of 2. So A is just 32 square root of 2. So we're done with our 45, 45, 90. Let's look at this 30, 60, 90 triangle now. That means that C is our X because it's across from 30 degrees. B is our X squared root of 3 because it's across from 60. And that means that 32 equals 2X. That's going to allow us to find that X. Ooh, forgot that. So that means that X equals 16. So when we put that in, that means C equals 16 and B equals 16 square root of 3. So you see how we just put it all together and it works out beautifully. All right, let's do the next example, which is a 30, 60, 90. So again, across from 30, this is our X. And we don't even have to write the rest in because we're just going to fill it in. So if X is 11, that means across from 60 is 11 times the square root of 3. And that means the Y, which is our hypotenuse, is 2 times 11, which is 22. That was an easy one. All right, let's look at the next example. we have two 30, 60, 90 triangles. So let's look at what we're given. You'll see that, let's just look at this triangle right here. You'll see that this is 60 degrees, which means that this has to be 30, which means this is our x for that 30, 60, 90 triangle. So that means if we wanted to find this value, which is the hypotenuse, it's 2 times 7 square root of 3, and that gives us 14 square root of 3. And that means if to solve this other right triangle, we have to have this value, which is across from 60 degrees, which is that means that it is this 7 square root of 3 times square root of 3. So 7 square root of 3 times the square root of 3 would be 7 times 3, which is 21. Because this is x square root of 3. Okay, now let's look at the other triangle that we want to solve. It is this triangle right here, and we have some parts of it. So we know that here is 21. That's across from 30, which means that's our x. So to find z is just going to be across from 60 degrees. So this is going to be x square root of 3, which means it's going to be 21 square root of 3. So we're just kind of putting all of those things together for these problems. If you would like to ask me about the next 4 problems, we can do those in class together. Also, they're really good practice for you to do on your own and then come have me check to make sure that you did them correctly.